As far as assignments go, the equations by factoring, that was due last night. It seems like pretty much everybody in here worked on it. And so the quiz is due tonight. And then after you do the quiz, you can focus on practicing for the midterm. So for this week and next week, there's three things you really need to focus on. Once you get these three things done, then you don't have to worry about this class for this week or next week. And that's take the quiz, which is due tonight. That's one of the things. Anything pertaining to studying and taking the midterm, which for some of you, I sent out this email before and I'll send it out again. Some of you, that might be Monday that you're taking the test. Some of you, that might be Wednesday. And then that workbook assignment that I assigned in class on Wednesday, workbook number 4, and I'll send out an email about that as well. I'll pick that up the following Friday. So that's the three main things, and the sooner you get those out of the way, that means you don't have to worry about much for this class. So just a heads up for everything going on with this class. Again, we're not having class next week. It's only midterm testing. So you don't have to show up to one of these virtual sessions. You don't have to, show up in class or in person. I'm not lecturing next week. It's just midterm week. So that means you pretty much get a day off. So besides for that, that's really all I can think of. Any other information I might say, as well as reiterating anything I've just said, that'll come in the form of an email I'll send out now that the ProctorU stuff is closed off. So besides for that, I suppose let's go ahead and start practicing for the midterm. So I had a few questions about, is the midterm going to be online? The answer is yes, the midterm will be online. And some of you asked, well, where is it? It will pop up on Monday. It'll be, it'll be its own link. It'll be pretty obvious. It'll be right below practice problems here. So really, it'll be a test you take, just like the practice test we're going to do here, or the Unit 1, more like the Unit 1 assessment that you took. It's going to be fairly similar to that. Okay, I believe there's going to be 17 questions on the midterm. You have 70 minutes to complete it. So once I confirm that, I can send that in the email as well. But in any case, let's go ahead and, unless anyone has any questions about anything, then we can go ahead and get started. So if not, then we'll just start off one problem at a time and just discuss strategies on doing each problem. So this problem, a little bit different when you view these problems out of context, without a particular section for which they stem from, which means you have to sort of not only know how to apply the process, but know which one to use. Now that, for example, it's not immediately known that this comes from the U substitution section, but that is what we're going to do in this problem. And really the thought process behind that is the fact that for this problem, it's really close to a quadratic form. If the x to the 2 over 3 here, if that was, say, a u squared, and then the x to the 1 over 3 here, that was a u, that would work out very nicely, as that would be a quadratic form, and we can utilize that appropriately. So it turns out we can use that by using u substitution. So that's sort of the thought process, is that you get this standard equation that you're expected to solve, and you see that, well, it's really close to a quadratic. If I just swap some variables out, it would be a quadratic. So as we mentioned in class, normally the middle variable is a good indication of what the u substitution is. And that works out very nicely because the next one, because there's now a 2 in the exponent instead of a 1, that's a good indication that this would represent u squared. And so we can go ahead and make that appropriate substitution. So 3u squared, because x to the 2 over 3, that's u squared, minus 20u minus 7 is equal to 0. And then it's a matter of factoring. So factoring, so we would utilize, you can utilize either the quadratic formula or the AC method. I'm going to use the AC method, but you're more than welcome to use the quadratic formula. You will get the same answers. So A is 3, C is negative 7, so that's 3 times negative 7, which is equal to negative 21. And again, you could factor any way you want. If you use guess and check, which is another method, you're more than welcome to use that method or any other one that you might know. You don't have to use this one. So two numbers that multiply to give you negative 21 add together to give you the negative 20 here in the middle. Seems to be negative 21 and positive 1. So now we can replace that middle term with the pair of numbers that we found. So negative 21u plus really 1u minus 7 is equal to 0. And we can group. So we can factor by grouping. The first group, they both have 3u in common. In fact, I'll start writing this up over here. So the first group, they both have 3u in common. You factor that out and you just get u minus 7, which makes perfect sense because the next group is u minus 7. We don't even have to factor anything out. If you want, you can assume that you just factored out a 1. So we talked about this in class, maybe last time or the time before. So finally, factoring by grouping, there's u minus 7 in common, which we can factor out. And once we factor that out, the question is what remains? What remains is 3u plus 1 is equal to 0. Which then tells us that each one of these can be set individually equal to 0. So then we get values for u, but not for x. We only have them for u, which means these are not good enough. We have to do one more step, and that requires, so hopefully you remember, for u substitution, we established a rule in the very beginning, which we need to bring back. So we bring the rule back. We know that u is 7. And u is negative 1 over 3. So hopefully you remember x to the 1 over 3 is the same thing as the third root of x. So with that being said, the way to get rid of a 1/3 power is to take a third power. Let me grab my calculator right fast. Okay. 7 raised to the third, 343. And then negative 1/3 to the third. That'll be negative 1/27. And so we get two answers. So does anyone have any questions about this problem here? Well, if not, let's go ahead and move on to the next problem. I'm not going to talk about this one, only because I talked about it on Wednesday. So I talked about this problem exactly on Wednesday, and I'd rather just do a wider diversity of problems. So hopefully that's okay. In fact, I think the answer is 16. 16. Yeah, okay, yeah. So I did this one Wednesday in class. So if you watched that video, or if you were here, then you can refer to that. So let's go ahead and look at this one then. Which you might recognize this one from the class notes. But for this problem, your thought process should be, all right, well, it's asking me to solve this. And so one way you could technically solve this is by FOILing this out and then distributing the 8 and then distributing the negative 15 and solving for all of that. But it's not very practical, especially in comparison to what we know now. And so seeing this pattern here elicits a method of substitution. So that's just to help with the thought process. Detecting any of these patterns is really a good thing in terms of eliciting a substitution method of some sort. And in particular, what that tells us is u would be here and then u squared would be here, primarily because the square gives us a good indication of that. Remember, all the numbers stay. The numbers on the outside stay. Here it would be u is equal to s plus 3. That would be the u here in this case. Which, once we have that established, now we have 8u squared minus 15u is equal to 2. And let's go ahead and move the 2 over. Move the 2 over just to put this in standard form. And from here, it's a quadratic for which we can solve. So again, we can utilize the AC method, or you can use the quadratic formula. You will get the same answers either way. In fact, I think I'm going to use the quadratic formula just to change it up a little bit and make sure everyone's familiar with the formula. You can use the AC method as well. I'm just going to change it up a little bit. So with the quadratic formula, you can use the quadratic formula anytime. You don't have to use factoring, but I have a suspicion that the quadratic formula will be needed on the test. So let's just make sure we all know how to use it. So A would be 8, B would be negative 15, and C is negative 2. And again, you can use the AC method. It doesn't matter. It's up to you. I'm just trying to change it up a little bit. So the quadratic formula. So what this says is that u is going to be equal, because we have u's and not x's, so u is equal to negative b plus or minus the square root of negative, or b squared minus 4 times a times c, all of this over 2 times 8. The workbook pages, I talked about those Wednesday in class. I will also send out an email as well about what they are. Those are due the following Friday. So from here, minus negative 15 is positive 15, plus or minus the square root of, and remember when I talked about the quadratic formula, I said take everything under the square root here and just throw all of that straight in the calculator. And you should get 289. So not the square root part itself, everything under the square root first. And this is just good in general. Now what's interesting here is sometimes the square root of whatever the number is not a nice number. You will notice here that the square root of 89 is in fact 17, which sometimes that happens, sometimes that doesn't, which is why I normally encourage the intermediate step with the square root symbol first, instead of just trying to throw everything in your calculator at once. So we get one answer from the plus sign, and we get one answer from the minus sign. So here we get 32 over 16, which is just 2. Then here we get negative 2 over 16, which is negative 1 over 8. But we found u values and not, well, s values in this case, because they have s's here. So the rule that we had established that will bring us back to the original variable u is equal to s plus 3. So one of the u's we found was 2. The other one we found was negative 1 over 8. And all you do to solve for the initial variable, you just subtract 3 on both sides. (1/8 minus 3 is (25/8). So we get 2 answers, and that'll be it. So to re-emphasize something I hopefully mentioned last time in class, 2/3 of the material on the midterm will come from the sections that we covered after the first unit test. So 2/3 of the material in the midterm will be on linear equations, quadratic equations, radical equations, the U substitution stuff, and factoring by grouping. That'll be 2/3 of the midterm. So the majority of the midterm will be on stuff like this, and 1/3 of the midterm will be on stuff that pertained to the first unit assessment. So that's why when you take the practice test, you'll probably notice a predominant amount of linear, quadratic, radical, quadratic type, and factoring by grouping problems. So does anyone have any questions before I move on? Okay, I'll go ahead and do that. So I think it's good to expect a domain problem on the test, which means you need to remember what that means and how to find it for several situations. So if you're looking for the domain of the square root of 8x plus 8, or any square root in general, hopefully you remember, and if not, I'll re-emphasize it here because it's been a few weeks. The domain of a square root means you take everything underneath the square root, so 8x plus 8, and you set that greater than or equal to 0. And this makes sense because what can we take the square root of in general? Square root of a positive number is fine. Square root of 0 is fine. Square root of a negative number is not fine. So naturally it makes sense to set everything under the square root greater than or equal to 0. So that's just more so conceptual, but. Or if you want to just memorize it, then it's exactly this. But if you memorize that, it really doesn't work out too badly. You subtract 8 on both sides and you divide both sides by 8. And we can keep the answer like this. In fact, we want to, because it wants an inequality or a compound inequality, which is exactly, so that they do not want interval notation. So we would actually put this answer because they are not looking for interval notation. Does anyone have any questions about this one? So that's all there is to this one. Now, I did have someone ask me what happens if you were to put this in as your answer instead. And I feel as though I recall seeing in the past that my math lab marked this wrong, but this correct, which is weird because they are the same exact thing. So I would recommend to just stay safe and format it as such. I don't know if MyMathLab accepts that format or not, which, as you can tell, the only difference is that everything is reflected. But I really have no clue, but I could have sworn I've seen that form wrong, even though it's perfectly correct. It might just be a MyMathLab.
So if you put it in like that now and hit submit, would it show you if it was
Other
wrong?
than that, let's go ahead and move on. So this one is one of those linear equation problems that we talked about. So for this word problem, it's, well, what does it mean for something to get marked up by 30%? For something to get marked up by 30%, you would have to take that amount and add 30% of that exact amount. So that's, you take the original amount, you add 30% of that amount to get the new amount. So that's what it looks like in general. And they're saying that there was a book that came in, they marked it up by 30%, and then the new price was $85. So that's what they're saying. So they took a book, they marked it up 30%, and now it's $85. And they want to know what the original price was. The good thing about setting up the problem as a linear equation like this is that you may notice you have like terms, where the coefficient of that's assumed to be 1. So really what you have is 1 plus 0.3, which is 1.3. So that's just adding like terms. And from here, you just get x by dividing 1.3 to get x by itself. And the problem says round to 2 decimal places, which makes sense because this is money. And that's what I get. That would have been the original price before the 30% markup. Okay, so let's move on to another one. So it might be expected that there would be 1 or 2 types of just standard quadratic solving problems. So notice there's no bells and whistles. It's just a quadratic. It's just a quadratic. So there's no weird exponents, there's no fractions, nothing like that. It's just a quadratic. And so it is up to you to use any method you prefer to solve this. Any method, I'm going to just use the AC method. Again, you can use the quadratic formula and you will get the exact same answers. So with this here, I'll just rewrite it. Well, AC, A is 8, C is 15. Which is 120. And we need to find 2 numbers that multiply to give us 120 and add together to give us 14. So As I explained before, and as I'll explain here again, normally I'll just take the 120 and just start dividing numbers and seeing if I get a match. Which looks like I already have one. And that should be negative, by the way. Negative 120. So they need to multiply to give us negative 120. So what I have is 20 and negative 6. Because notice, 20 times negative 6 is negative 120, and 20 plus negative 6 is 14, which is the middle number. So it works out very nicely. So from here, plus 20x minus 6x minus 15 is equal to 0. So now we are replacing the 14x with the pair of numbers we found, and we can factor by grouping. For the first grouping, it looks like they have a 4x in common. So 4x. So 8 doesn't go into 20, so we can't use 8, but we can use 4. And they both have an x in common. So 8 divided by 4 is 2, and there's one x left over, and then plus really 5. And then for the next two, it looks like a negative 3. They both have a negative 3 in common. So that would be 2x, well, plus 5. Which is perfect because these two factors match up, as they should for the AC method, or just factoring by grouping in general. We can go ahead and factor out that common factor. And once we do that, we are left with 4x minus 3. Which means each factor can be individually set equal to 0. So for one of them, x is negative 5 over 2. And for the other one, looks like x is equal to 3 over 4. So it's just a standard solving problem for just a quadratic with no additional stuff thrown in. So does anyone have any questions about this one? So if not, go ahead and move on. So for this problem here, there's a bunch of fractions. So naturally, I start to consider the least common denominator. Now, excuse me. So now what I notice is, well, all of the denominators, at least they're factored. So in particular, this denominator right here, it's already factored, which means it's really easy to identify the components and determine what the least common denominator would be. So when we start to consider the least common denominator, we need to have a factor for every component we see. So x minus 4 needs to have some part in our LCD in x. And then we already have x and x minus 4, so we do not need to repeat them. So our LCD would be exactly x times x minus 4, just like this. We have an x for all the x's scattered about, and we have x minus 4 for all the x minus 4 scattered about. So I just rewrote the original equation, but now we're going to multiply every term by x times x minus 4. And we should expect a considerable amount of cancellation. So x minus 4 and x minus 4, which would be 7. See, I see a 7, I see an x, and I see x minus 3. X's cancel over here, and we are left with 2 times x minus 4. And that is equal to, well, x cancels with x minus 4 cancels with x minus 4, and we are just left with negative 2. And from here, we can distribute. Distribute. That is 7x squared minus 21x plus 2x minus 8 is equal to negative 2. And finally, from here, all we have left is to combine some like terms. These are like terms, and then I can move the negative 2 over and combine positive 2 with negative 8. And once we do all of that, we get 7x squared minus 19x is negative 21 plus 2. And then negative 8 plus the 2 that we brought over is negative 6. So hopefully everyone's good here so far, because now we have set up the quadratic. The problem does say solve it by factoring. Really, it doesn't matter. You still get the same answers regardless, whether you factor or use the quadratic formula. I suppose I'll stick to factoring, but you don't have to, even though it says factoring, it doesn't really make too much of a difference if you use factoring or the quadratic formula. So the AC method, I will use the AC method here. So 7 and negative 6, that's A and C respectively. 7 times negative 6, that's negative 42. We need two numbers that multiply to give us negative 42 and add together to give us the negative 19 here. So of course 6 and 7 do not work. 3 and 14 do not work. 2 and 21 do work. So in particular, negative 21 and positive 2. Negative 21 times 2 is negative 42, and their sum is negative 19. So now we can replace that middle term with negative 21x plus 2x to match the two numbers that we found. Minus 6 is equal to 0. And now we can factor by grouping. So between the first grouping, they both seem to have a 7x in common. So remember, we're dividing out the 7, so that's why when you take out 7 from 21, you're actually dividing. So negative 21 divided by 7 is negative 3, and not negative 14 or something. The next grouping, they both seem to have a 2 in common. So I'll factor out a 2, which we are left with x minus 3. Again, we're dividing out the 2, which means negative 6 divided by 2 is negative 3. We seem to notice the repetition here, which is x minus 3, which we will factor out. And once those are gone, we are left with 7x plus 2. And we can go ahead and solve for x's in both cases. So we get two answers here. We get 3 and negative 2 over 7. And normally we need to check our answers in particular, because since there's fractions at the very beginning of the problem, there's a chance we could have extra solutions that don't work. So in particular, since there's an x in the denominator, one of the numbers that we would have to toss would be x is 0. And then over here, x would not be able to equal positive 4. But we don't have either of those numbers, so we don't have to restrict anything. If one of our answers would have been a 4 or 0, we would have had to reject them. But both of these are fine. 3 is fine, negative 2 over 7. Those numbers are not 0 and 4, so we keep them. Just like that. Does anyone have any questions up to this point? If not, I will keep going. Okay, let's do this one. So this is a standard inequality problem. So I'll write the compound inequality off to the side. So that is a compound inequality because there's two inequality symbols. And so to solve for x, because there is an x there and we want to solve for it, we will need to slowly start to isolate the x in the middle here. The first thing we would have to do is subtract 6 on, well, really we're inclined to say on both sides, but there's 3 sides now. So we'd have to subtract 6 from here, and from here, because this is a compound inequality. So that would be negative 40 less than or equal to, these two cancel out. Negative 5x is less than or equal to, what is that, 16? And then to get x by itself completely, we have to divide everything by negative 5. And remember, if you multiply or divide by a negative number, you have to flip the signs. You would have to flip the signs. So this one's just negative 16 over 5. As you can notice over here, there's a negative 16 over 5. And then on the other side, negative 40 divided by negative 5 is positive 8. And so this makes sense because if you did not flip the signs, then you would imply that 8 is smaller than negative 16 over 5. That doesn't make any sense. A positive is, of course, going to be larger than a negative. So then it doesn't really seem like too much of a point of contingency about what the numbers are since we have multiple choice. If anything, C is definitely wrong because they have negative 8 and we have positive 8. So if anything, that's one indication. Additionally, I could tell that A and C are instantly going to be wrong, or A and D rather, because, well, the signs. That is a strictly greater than sign. We do not have a strictly greater than sign anywhere in this inequality. And then same thing over here. We do not have a strictly greater than sign anywhere. So really we are left with choice B, merely by process of elimination. And so finally, it's a matter of graphing this on using the correct number line. Now, you may notice that negative 16 over 5, so if anything, 8 is a little bit easier to find. So 8 would be right here or right here. Well, 8 is right here, but D is far off from that, and 8 is right here as well. But negative 16 over 5 is equal to, what's that, negative 3.125? Is that it? Oh, 3.2, sorry. 3.2. So that gives us an idea that negative 3.2, it's going to be somewhere a little bit past negative 3, right there, or right here. So if anything, it comes down to the brackets versus the parentheses, and we've already established that we cannot have parentheses anywhere because we have all strictly equal to signs, which all implies brackets. So the answer choice would have to be choice C. Yeah, Shannon's answer your question. Yeah, I noticed that as well. I'll answer your question in more detail in a second, Shannon. So be allowed scratch work. So when you take your test, so if you're taking it in person, they will give you scratch paper. If you take it remotely, you will provide your own. But the proctor through ProctorU is going to make you show every side of your paper to make sure you don't have anything written down. But yeah, you in person you will be given scratch paper. And since it is 8:50, we are out of class time. I wanted to dedicate the rest of any time moving forward to just be optional. So I can do more problems, or if you have specific problems you want me to do or anything like that, I'm more than happy to do them, or I could just keep doing problems for the practice test. And yeah, I can go through the rest of it, but we are out of class time, so you don't have to stick around any longer if you feel prepared. But other than that, I'll keep going through problems as if it were a standard class time. So I suppose, so Shannon, did I answer your question about the negative 16 over 5? So I mean, this mark right here is negative 3.2 or negative 16 over 5. Because notice negative goes, the larger the negative sign gets, the more to the left it goes. So notice how even though negative 3 is right here, the bracket is just a little bit to the left of that. And that slight bit to the left is the 0.2 that comes from the decimal approximation, or the decimal form of negative 16 over 5. So that's the reason why. And I can't really think about how to explain it any more thoroughly than that. Cool. So other than that, I'll just keep going through the practice test for however long until I have to start preparing for my next section. So let's go ahead and just keep going. Okay, so here we'll start off with part A. So they give us this function. They just want us to do a bunch of stuff to it. Part A, they just want us to plug in 0 for all the x's. So that part should be pretty straightforward. Just plug in 0 for x. And then part B, fairly similar. Just plug in negative 1 for all of the x's. And that's it. So those two should be pretty straightforward. Now I want to make sure I feel as though this problem probably will not show up on the test. The reason I'm saying that is this problem takes a while and I'd rather focus on other problems. And if I don't have to do this problem, I'd rather not do it. Let's see. I'm going to jot this problem down. If it does seem relevant, then I'll make a correction in an email or something. I'd rather not do this problem because it takes a while. And yeah, I could do the x plus h1. That's fine. So I'll just skip the other two. Just put 5 divided by x squared plus 10x plus 26. 2x divided by 4x squared plus 41. So again, I'm gonna just skip that part for now. And so for part H, so there might be just a typical x plus h problem on the test. I don't think it's going to refer to a function like this, but in case it does, it just means that every x that you have is replaced with x plus h. So notice that every x now becomes x plus h, as I wrote down here. And pretty much the main thing is realizing that you have to FOIL. Realizing you have to FOIL here to simplify this. So x plus h is in the numerator. We have x squared plus xh plus xh plus h squared plus 1. And we have like terms. So yeah, if anything, the x plus h one, it might come up for you might want to expect an x plus h problem, maybe for a different type of function, such as, I would imagine for something like this. Ask you to find f of x plus h for something like this. That's what I would anticipate. But that's how you do it for this problem here. So, are there any questions here? And yeah, if you wanted to do the other two on your own that I skipped over, those are the right answers for those. If you wanted to work them out. But besides for that, let's go ahead and move on. So this is whenever negative exponents are involved with inequalities. And so I wrote down several rules at the end of the linear equality and inequality section, where one of the rules in particular would emphasize or, well, imply that if you have a situation like this with a negative exponent and an inequality, then you can pretty much get rid of the negative 1 exponent. So this is what that rule stated. But once you realize that, the problem works out pretty nicely. So you get negative 5 over 6, it looks like. However, they want the answer in interval notation. So this would not be good enough. So we need to figure out how does that translate to interval notation. Since x is less than this number, that means it goes towards negative infinity. And then it goes all the way up to negative 5 over 6, which is not included. So we use a parenthesis because we do not have an equal to component. So our answer is precisely this. And from here, since x is going to negative infinity instead of positive infinity, b and d are automatically out because b and d both go to positive infinity. And we need to pick the one that has a parenthesis instead of a bracket, as symbolized over here. So C would be the answer. Okay. Let's keep going. Not going to do that one. It doesn't matter. Yeah, it might be good to expect one transformation problem on here. I wouldn't imagine there would be more than one. But if anything, it definitely requires that you know which function the V shape corresponds to. This is an absolute value. So if anything, this answer choice right here is out because we need an absolute value of some kind. Now, another indication is that we are going to the left. How many units is that? It looks like 6 because these go by increments of 2. So 2, 4, 6. So when we go to the left 6, that means you have to add 6 to the x variable directly. Really, there's only one that does that. And it has the negative in front, which when there's a negative applied to the whole function, it means you flip about the x-axis, which makes sense. The V shape, you flip about the x-axis, and that would completely flip downwards. So these are some indications that you can use. So that one just primarily tests your knowledge of parent functions. This could be a problem that you could possibly expect on the midterm. And this one, I'm pretty sure one like this came up on the Unit 1 assessment. The rule of thumb that I gave for this one, if you see the word maximize anywhere, if you see the word maximize or minimize anywhere, that tells you you're going to be finding the vertex in some regard. And so we do have a quadratic function here. And so if we're finding the vertex, that means you need to know what the vertex is. So the vertex, remember, it has 2 parts. It has the x component and the y component. The x component is negative b over 2a. So a is negative 8. B is 16,000. So that's negative 16,000 divided by 2 times negative 8. What is that, 1,000 or something? instantly tells you first entry. And then the maximum revenue itself, it just wants you to find the y coordinate. So you just plug in the x coordinate back into the original function. I get a pretty large number. It's 8 million. So that's all you do for any maximum or minimum problem that you see. It's just the vertex. You're extrapolating the vertex in some manner. So if you see that one come up on the test, try not to overthink it with all of the wording. Maximize or minimize is a pretty explicit indicator for determining the vertex. Okay. So we're going to go ahead and, so I feel like I worked this one out Wednesday. So should I work this one out? No. Did I work this one out on Wednesday? I feel like I did. Okay, well, let's look at other problems. I know 0 is one of the answers. I don't know the other one offhand. Linear function. Probably just skip this one over with right quick. It is just a linear function, not a quadratic or anything like that. It's just a linear function. We can graph the y-intercept, which is positive 5, and then the slope tells us we go down 3, 1, 2, 3, and then to the right 5, 2, 3, 4, 5. And from there, we can determine the domain and the range and all of that stuff. So domain and range, negative infinity to positive infinity. Things go up, down, left, and right infinitely. We can also use this graph to determine that the function is never increasing and it's always decreasing. Because the line is just, well, I think everything's reflected on my end. So everything's going straight down. So graph really helps there. Now let's move on. I think this is a good one. This is definitely a good one to look at. So I was talking about the domain of a square root earlier. So I think the domain of a fraction is good to look at, as well. So the domain of a fraction set denominator not equal to 0 and solve for x. So what's the denominator? Well, the denominator is x to the third plus 9x. Set that not equal to 0. And so this is a factor-based problem. We can factor out an x because they both have an x in common, which means we can set both of them not equal to 0. One of them's already solved for. And the other one, we need to, well, solve for x. Subtract 9 on both sides, and then we can apply the square root. The problem, we can't take a square root of the negative. Can't take square root of negative. So since we run into this issue, that means we get no answers from that whole expression. And we have to rely on what we have over here. So really the answer is x is not equal to 0. The problem, we want interval notation. X not equal to 0 is not interval notation, it's an inequality. So instead, we have to think about what that means on a number line. Here's 0. Means everything over here is okay. Skip this, so we put an open circle, and then everything over here is okay. And for each one of those intervals, negative infinity, so negative infinity, it goes all the way to 0. We use a parenthesis because 0 is not included. We have to use the union to connect it to the rightmost interval, 0 to positive infinity. And this would be the final answer. So it might be expected that there may be a domain of a fraction problem on the test. Maybe not as extreme as this one, or possibly as extreme as this one, but it's just good to consider a few examples of that. So what was the square root one that we talked about before? I'll do this. I'll do this one, and then I will have to call it a day because I have another class after this. So we're finding the real solutions to this. And so we did one fairly similar in the notes. The first thing we did, so this is a radical equation problem. So in general, with radical equations, we first have to isolate the radical. So what I'm going to go ahead and do, divide both sides by 2. And now the radical is fully isolated. There's nothing on that side except for the radical itself. And so from here, we can square both sides. So what did we do after we isolated the radical? We got rid of the radical by applying the power that matches the root. So it's a square root or a second root, so we take a second power. So now that's x squared over 4, because the 2 in the denominator gets squared as well. And then we get 6x minus 36, which we can then proceed to multiply out the 4. So that's 24x minus 36 times 4. And we can factor from here. problem. No problem, Molly. So with 12, so we get 12, and then we would technically have to check our answers because square root in the beginning. So that would be 2 times the square root of all of that stuff. 6 times 12 minus 36. That is 36. So that is just 12, which is good, which matches the 12 on the other side. So I have to prepare for my next class in about 10 minutes. So I will call it a day here. I will send out an email after, well, maybe a little bit later on today about what you have to do for the test, just to make sure that you go to the right place or you have everything set up correctly and all of that stuff. So other than that, that is all I have. Have a good day.